let's talk about coterminal and reference angles using radians. Now, I have a problem here that is supposed to help us to start this conversation. So this time I'm giving you an angle, but I'm giving it to you in radians. And we're trying to do the same thing. We're trying to find something coterminal and eventually the reference. Now, I like that you're starting in or you're thinking about it, but let's maybe kind of do this a little more together because I don't want you to get any bad habits. The first bad habit is that we just want to automatically switch to degrees. Now, the reason that's a bad habit is because it might not be necessary. Okay, now if you're like, oh man, I was changing this to degrees, I thought I was on the right track. It's not wrong, but it's just maybe not necessary. What does it mean to find something coterminal? It just means that you're going to add or subtract a revolution. What's a revolution in radians? You're going to have a radian revolution. You're going to march on the hill and you're going to bring with you 2 pi. That's a radian revolution. Okay, wait, does that mean I can add or subtract 2 pi? Yes. Not only can you, but you should. You should add or subtract 2 pi. Now, that's a little different, right? I get it. It's not just like a nice little angle in degrees. How do you add something like 2 pi to 3 pi over 5? A little bit of like we did, I think, a day or two ago. You have to start thinking about like fractions and common denominators. So listen, the denominator's 5. I guarantee we need a denominator of 5. I hope you realize you can't just put a 5 down there. You have to also multiply 5 to the numerator. You see, I didn't just put a 5 there. I multiplied it there. So I'm going to multiply the top by 5 and get 10 pi over 5. 10 pi over 5. I'm actually suggesting that you're not worried so much about a calculator because the numbers I give you, you don't need a calculator. I want you to take 3 pi plus 10 pi and get 13 pi over 5 and be done, okay? Because you can add a revolution. You can add a radian revolution. There's a baseball team called the Revolution. I'm going to start my own league. It'll be the Math League, and we'll be the Radian Revolutions. I can't tell if you're smiling or not, so I'll just assume that you thought that was funny. Subtract 2 pi. Subtract 2 pi. Realize that you're subtracting a revolution. Grace? Great, let's talk about it again, because what's happening here is we have a fraction minus a non-fraction. You need a common d, you need a common denominator. The denominator is going to be 5. So what I'm going to do is multiply the top and bottom of this by 5. Now, I didn't show this, but make sure we realize that the bottom is 1, kind of like always. So I'm going to multiply now the top by 5. So Grace, if you multiply 2 by 5, that's where we got the 10. But I'm going to multiply the bottom by 5. And that's why it kind of looks like we're just putting a 5 down there. So the little rule is, change the top and bottom the same way, multiply, in this case, by 5. So 3 pi minus 10 pi, not supposed to be too tricky. 3 pi minus 10 pi, negative 7 pi. Negative 7 pi over 5. How about the reference? I'd like you to think about it, but I think we'll kind of talk about it together. I don't want you to get a bad habit, but just think about it a little bit. Now, I'll be honest, what I'm kind of thinking is when your classmate said, when he said that we're going to subtract with 180, maybe you're kind of thinking about that. But why were we subtracting with 180? Because we were really trying to subtract with the x-axis. The x-axis. Now, how's that going for you? The x-axis in radian land. Over here, the x-axis could be 0, or it could be, in radian land, 2 pi. Okay, so the x-axis is referred to as 0 or 2 pi. How about on this side? Pi. Okay, so you get what we're trying to do. We're trying to do the same thing, but we're trying to do it with radians. Now, you should be saying, okay, but where is this? Okay, hey, that's what you should be wondering. Where is it? Now, you could look it up. Where would you look it up? You could look it up on that big crazy circle we made that one day. And maybe you kind of get lucky and you find 3 pi over 5. Maybe you have to convert it. Now, I know I got done saying don't convert the other one, but you realize the reason we're converting this is just so we know where it's located. And you got to know. Okay, now 3 pi over 5, if you convert it, so, I guess we could kind of talk about that, although you did that for your homework yesterday. I'm not a big shortcut guy because people forget shortcuts. You learn it today, you forget it tomorrow. So set up the proportion, but when you set it up, maybe the shortcut sort of comes back to you, or maybe I should say you start to notice a shortcut, and that is that all you're really going to do is multiply 3/5 times 180. It's kind of like you're finding 3/5 of 180. Okay, again, if you notice that. What is 3/5 of 180? I actually didn't do it. Go ahead, Andrew. Thank you. 108. Now, here's where I really want you to listen. And for some of you, this is it. After you hear this, you're ready to finish the, sort of the lesson. So just listen. The reason we convert it is because we just really need to know where it is. Now that I know that 3 pi over 5 is right here, we can subtract with the x-axis. What I'm trying to say is we can use pi. We can use pi. This is a little harder, okay? I know you guys know how to use 180. If you're like, can't I just use 180? You could, but if we do it with pi, okay, then we're going to get that answer in radians. Let's do it that way. Okay, now, which way do you subtract? You have to understand that pi is bigger than 3/5 of pi. Pi is bigger. So that means I'm going to subtract the big minus the small. Pi minus 3/5 of pi. It's one of these again. Common denominator, trying to change. Now, it's a denominator of 5, so that means I can make the top and bottom change by 5. 5 pi minus 3 pi is 2 pi. 2 pi over 5. This space right here, this size, this angle is 2 pi over 5. Call it the reference. Now, I've done something. It's called some math etiquette. It's Miss Naylor's little make-believe math etiquette book. If you open up the math etiquette book to page 3.14, it says, if the problem starts in radians, then your answers are in radians. If the problem starts in radians, then my answer's in radians. So what are we going to do about this? Okay, well, here's the deal. You could use it. Okay, you could use it because this is 108. This is 180. And we learned the other day, actually it was the first day, that if you subtract, you'll get the reference. 72. I don't really want to call it a problem, but here's the thing. If you write 72, you're not following math etiquette. In the math etiquette book, it says, if a problem starts in radians, my answer is in radians. So, could you turn this back into radians? Sure. You just got done doing it for your homework last night. Okay. Now, what I'm saying is you're allowed to do this, but I'm more asking, do you know how? Can you? So, can you take 72 degrees and switch it back? It's a little extra work. Here I am kind of writing more things. But hear me out. You can do this. So I'm converting. I should maybe say what we're doing here. We're converting. The problem continues. You get 72 pi over 180. Okay, because basically we just multiplied 72 so we could solve for x. But, you got to clean that up because 72 over 180, it's not reduced. So, all right, we got to keep going. Now, we're not going to do this all year, but it's a skill that we have to have. So if you're doing it this way, you have to reduce 72 and 180. I guess eventually it's going to reduce by 36. Okay, it's going to reduce by 36. I kind of know that because I've seen the numbers. You need to play around until you get it down to, down to 2 pi over 5. Down to 2 pi over 5. Now, that was meant to be a little bit of a transition problem, but it also can serve as some notes and examples. I'd like to do a couple more. I want to make sure that we're good. One problem is usually not enough. So let's kind of make it official. Coterminal. Now, you should kind of feel like you've heard this now a couple times, but let's make it official. Coterminal, okay, is simply going to be theta plus or minus 2 pi. Theta plus or minus 2 pi. This isn't too bad. You should be able to add or subtract 2 pi and not mess around anymore. You don't need to do anything with degrees. You don't need to convert. How about, let me give you one, because I guess I haven't really given you one to kind of do on your own. How about 5 pi over 6? Usually I'll ask you for a positive and a negative coterminal. Do you want to see if you can find a pair, a positive and a negative coterminal. Well, it's pretty good. The only mistake I see, which is not uncommon, is just correctly changing 2 pi to have a common denominator of 6 this time. Okay, so yeah, I need to put a 6 there, but that means the top is going to change to be 12, okay, because you multiplied by 6. So 5 pi and 12 pi, 17 pi. Good news is it's the same thing, just with a subtraction sign. So you're going to subtract 2 pi, but that's really like 12 pi over 6. So again, it turns into 12 pi. So now it's 5 minus 12, 5 pi minus 12 pi, negative 7 pi. Negative 7 pi over 6. Now, maybe you're saying, sounds good, Mr. Nail, I can do this, but do you realize what you're doing? I want to be that kind of teacher for you. Do you realize what these numbers are? Okay, this is hard. I'm not sure I completely understood it in high school. I don't want you to be the same. 5 pi over 6, it's an angle. It's about right here. Okay, how did I know that? I looked it up, okay, because we talked about it like 2 days ago. So 5 pi over 6 is right there. 17 pi over 6. It's a little weird, but watch. 17 pi over 6 is right there. It's like an extra spin. Negative 7 pi over 6. Now, maybe this can make a little more sense. That just means going backwards, but just to there. And that'll get me to negative 7 pi over 6. The good news is, as long as you understand one of these, they're all the same. And, most time kids understand the smaller one, 5 pi over 6. That was the first one I drew, but they're all in the same place. Let's do 1 or 2 more reference. Most of the time, if you're honest, kids will say a little harder. So, a reference. Now remember, a reference angle is always going to be that acute angle. It's always going to be acute with the terminal side and the x-axis. You don't need to write that down if you kind of remember that, but I do want to jog your memory from the first day. It's always acute, terminal side, x-axis. Here's the thing. The x-axis might be 0. It might be pi. It might be 2 pi. You have to understand that the x-axis could be any of those 3. Okay, a little bit like what we talked about the first time, or for that first problem. Here's the theta. It's in radians. We want to find the reference. Remember, we actually call that theta prime. So I want to use that notation, theta prime, the reference. Now listen, I kind of would like to go over this just so you can see it. kind of hear it and make sure that you realize this is what it takes. And first, you have to figure out where this is. Now, to figure out where this is, a lot of kids will convert it. It's fine. You're allowed to do that. If you convert this, or maybe you kind of remember or notice that there's a shortcut, that you're really just going to take 4/3 of 180. So, whatever you got to do, 4/3 of 180 happens to come out to be 240. Okay. But remember, we're converting it so that we can locate it. Now, at this point, I'm going to encourage you to try to do the problem in radians. When I say to try to do the problem in radians, that means that you think about the x-axis in radians. Okay, now the x-axis is over here. I guess kind of like the one we did a moment ago, that would be pi. And now we're just trying to subtract these two numbers. Okay, not the easiest thing to do, but if you try it, you're just going to subtract the big number minus the small number. The big number is 4 pi over 3 minus pi. Now remember, the reason we're subtracting pi is because that's the x-axis. And then you got yourself a little common denominator situation. So make a denominator of 3, and 4 pi minus 3 pi, bingo, gives you pi over 3. 4 pi minus 3 pi gives you pi over 3. That's the reference angle in here. Now I'm going to show this, but it'll be the last time I do. And I want to say, it's okay. You're allowed to do this. Some of you might do it. It is okay. What I'm talking about is continuing in degrees. If you continue in degrees, then you're thinking of the x-axis as 180. Then you're going to get 60. Then you're going to have to convert it back. And to convert it back means a little extra work, but you can do it. You just have to take those steps, set it up, proportion, multiply. You get 60 pi over 180. Okay, and I know we know what the answer is, but that would reduce the same. That would reduce to be pi over 3. But you'd have to do that. You'd have to switch it back to pi over 3. Let me give you one here. Instead of me doing it, let me give you a little time to think about it. It's a good problem. There's something that, at least this morning, you haven't seen yet, and you'll have to do it with this problem. So it's 7 pi over 4. 7 pi over 4. You're trying to find theta prime. You're trying to find the reference. hey, are you getting a positive answer? If for some reason it came out negative, maybe you just need to switch the way you subtracted. But you should get a positive answer. Now, just your x-axis. You're getting the right answer, but you just miscopied, so it's going to seem different.
Oh, okay.
For what you did, though, it's right.
Okay.
Your x-axis. It'll be a different. Oh, you flip the numbers. That's probably right for what you wrote down. It's just going to be different than 7 pi over 4. I'll tell you what, I'm impressed. Nice job. Keep learning. A lot of right answers, things that can be fixed. So, Riley, just start us. Like, what did you do first?
Well, first, I found 7 close to 180. Just find out that.
You're good. I think that's a good first step. I'm going to kind of do the obvious here that we now know where that is. What did you do next? What did you do next, Evan? What did you do next? Now, you're not the only person, okay? And I just wanted people to kind of hear that the problem with that is that 180 is not the x-axis that we desire for this problem, okay? But there is an x-axis that we can use. It's the one over here. Okay, now, can you take it from there? Like, what is the x-axis over here? Or, now, or 2 pi, right? Now, by the way, or 360. Okay, what we want to do is we just want to subtract with the correct one. Okay, it won't be 0 because if we subtract with 0, we're not going to get an acute answer. It's going to be too big. So we're going to want to subtract with one of these. Good. So if you're doing it in degrees, you could use 360, and that would be 45. If you're doing it in radians, Ian, how did you subtract it? Sorry, Ian. Yeah, you can subtract with 2 pi, which Ian correctly changed to be 8 pi. 8 pi over 4. All right, so we're subtracting with the x-axis, and now you get pi over 4. Let's be clear, that's the right answer. So if you got 45 degrees, you got to flip it back, you got to convert it back. Okay, and make sure you guys understand that pi over 4 is this space right here. Pi over 4 is this space. It's that angle. That was a little different because I threw at you a different x-axis. Okay, the x-axis is 360 or 2 pi. Okay, tomorrow there'll be, now this is not meant to like get you worked up, but I'm trying to just help you be ready tomorrow. There's going to be a little mini check. Maybe you kind of sense that we've been through some topics, so there'll be a little open notes mini check. Okay? If you're doing the homework, if you've been understanding as things are going on, you should do pretty well with that. So I don't want you to like worry, but know that tomorrow we're going to take a grade, and we'll be officially done with sort of these first topics. It's always open notes. So, but do the homework tonight to kind of figure out today's lesson, and we can talk about that, which we will.
Look at 1.3 on the classroom. Like 6 questions.
Help me out. Hold on, let me stop this.